Welcome to our video about factoring. What is factoring? It is a word that is used so often in math, and I think students get confused with what it really entails. And so I'm creating this video to show the main ways of factoring. I call this a factor tree. Basically, when you're asked to factor, your first step always is to look for a greatest common factor, or GCF. Then whatever you have remaining is most times usually comprised of 2 terms, 3 terms, or it has 4 terms. If it's any more than that, there's not really usually any more you can do. And this is all you're going to see for the majority of math that you'll probably take. 2 terms has the potential to be a difference of squares. 3 terms is most often what's called a quadratic trinomial. And 4 terms you can factor by grouping. We are going to delve into each one of these 4 things on these next slides and do some examples following this factor tree. The first step always when you're asked to factor is to look for a greatest common factor, GCF. That means the largest thing that can be pulled out of both terms that they have in common. We want to look for 2 different parts of a GCF, the number part and the variable part, because they can both be part of a GCF. So let's take a look at problem number 1. We're asked to factor this expression. This is a binomial expression, 2 terms, and we want to see if they have a number in common, a common factor. Out of 3 and 12, 3 can fit into both 3 and 12. 3 is the greatest common factor between the 2. We also want to look and see if they have a variable in common. They don't. This term has a variable x, but this one doesn't. So we cannot take a variable out because it's not common to both. So our greatest common factor is 3. And what are we left with? Basically now we are going backwards. We're breaking this down. We want to say if we pull a 3 out of here, what do we have to multiply to basically get back to what's written in black? So 3 times what will get us back to 3x squared? X squared. Then we need a minus sign. Then we think 3 times what will get us back to 12? 4. Now, in this case, some of you might recognize that this is a difference of squares and we would keep going. However, let's just change the directions to just factor out the GCF instead. We would keep going, but I am just talking about a GCF here. So we took out the 3. If you were to multiply the 3 back through using the distributive property, you'd get back to the original. Let's look at number 2. What do all of these terms have in common? They have an 8, a 4, and a 20. I know that we cannot take an x out because an x is not common to all 3 terms. Therefore, we cannot take an x out. Okay, so let's look at 8, 4, and 20. Is there a number that can fit into all 3 of those, right? That 8, 4, and 20 can be divided by. That number is 4. So 4 is our greatest common factor here. And then we are going to have 3 terms inside these parentheses because we have to multiply 4 by 3 different things to get back to the original problem. The first thing we have to multiply 4 by is 2x squared, because 4 times 2x squared will get us back to our original 8x squared. 4 times what will get us to 4x and x, and we put a plus sign. And then 4 times what will get us back to this minus 20, minus 5. Great. I'm going to change number 3 just real quick, so I'm actually going to add that to it for number 3. All right, let's take a look at, we have 17x plus 14x squared. Out of 17 and 14, there are no common factors other than 1, the factor for everything, but taking out a 1 is not going to help us. So we look at our variables. They both have x in them. The x that they have in common is just a plain x, just x. So x is our greatest common factor. X squared cannot be our greatest common factor because this term does not contain an x squared. They both contain just an x. This one contains more than that, but what they have in common is just an x. So we can take out the x as our GCF. We're left with 17 in our first term plus 14x. We have that because x times 17 will get us back to 17x, and x times 14x will get us back to 14x squared. All right, once you are done factoring out the GCF, we have to see what remains. So I screenshotted this from our first page. We did factor out the GCF, and now we're down this lane here, this branch of our factor tree. If you're left with two terms inside, then it could potentially be a difference of squares. Okay, so we had this example on the other page where we factored out the GCF of 3, so we were here on our factor tree, and then what remained? What remained in parentheses was a binomial. It had two terms. So we go down the two terms branch and we see, is it a difference of squares? Well, what is a difference of squares? Math is very literal, thankfully. So the term difference means that it has a minus sign in it, and the term squares means that they're both perfect squares. Whoops. All right. So does this have a minus sign in it? Yes. Are both of the terms being subtracted here, are they both perfect squares? Yes. This has a square root of x, and 4 has a square root of 2. So this is technically a difference of squares. The way that it is going to factor, keep the 3 out front, the way that this guy's going to factor here is we're going to take the square root of each. So the square root of x squared is just x, and we're going to write that first in each. The square root of 4 is 2, so we're going to write that second. And 1 plus, 1 minus. We have factored this completely. All right, let's say you're not convinced. Why does that work? So here we can check to make sure. We're going to check by multiplying through. So I'm going to multiply these two parentheses together, x times x times minus 2, 2 times x, and 2 times a minus 2 there. Let's see what we get. We have the 3 out front still. We have x squared minus 2x plus 2x, and then a minus 4. These terms here cancel out to 0, so we're left with 3 x squared minus 4, which is where we were here. And then if we multiply the 3 back through, we'll have 3x squared minus 12. Factoring is just reverse multiplication. You can always check your work through multiplication. All right, let's take a look at this next example here. We want to factor completely, so our first step is to see if there's a GCF. 4 and 9 have no common factors other than 1, and they do not have a variable in common either. So there's no GCF. We see we have two terms. We want to see if it's a difference of squares. Is this first term a perfect square? Yes. The square root's 2a. Is 9 a perfect square? Yes. Its square root is 3. Is it a difference? Is there a minus sign? Yes. All right, so we can factor this using the difference of squares method, two parentheses. We take the square root of the first term and write it first, 2a. We take the square root of the second term and write it second, 3. 1 plus, 1 minus. No, the order that you put plus or minus doesn't matter. And we have factored that completely. All right, let's take a look at what difference of squares is in general. So in general, difference of squares looks like this. If you have a squared minus b squared, if you have two perfect squares, it factors into a plus b, a minus b. So in this case, our a squared term was 4a squared, our b squared term was 9, and we took the square root of each one of those to get a and b. A and b were, respectively, 2a and 3. 1 plus, 1 minus. So that is generally what difference of squares is. Again, math terms are very straightforward, right? Mathematicians, not the most creative of people, at least when naming things. So a difference of squares is literally that, a difference of two squares. Okay, for this one, we are taking a look at the quadratic trinomials, and the section that we're on now is 3 terms. So if something has 3 terms, most of the time it's going to be a quadratic trinomial. Quadratic meaning it has an x squared or whatever variable squared as its highest exponent is squared. And trinomial meaning it has 3 terms. All right, ax squared plus bx plus c is the general form. We're going to take a look at when a is 1, so if we don't see anything here, or when a isn't 1. And you can use what's called the box method. I'm going to show two different methods here, but either one will work. All right, let's take a look at this first example here. We have 3x squared plus 39x minus 90. We want to first see if there is a GCF that we can factor out. That's always our first thing we want to look at, GCF. So there is a GCF, it is 3. When we take the 3 out, we're left with x squared plus 13x minus 30. And then what remains? We have a 3-term polynomial. It's a quadratic trinomial. Specifically, in parentheses, we actually have where a is 1 here. This 3 we're not going to worry about. It does have to be part of our final answer, but from here on out for the rest of the problem, you don't care about it. Let's take a look at the trinomial here on the inside. We want to find two numbers that are going to multiply to a times c. So our a value is 1, and our c value is a negative 30. So are there two numbers that are going to multiply to negative 30 that are going to add to 13? Yes, those numbers are, I had to think about it for a second, positive 15 and negative 2. Yeah, there's a lot of different ways to multiply to negative 30, but this is the only one that'll that'll add to 13. All right, so what we're going to do is rewrite the center. So this 3, I'm just not going to worry about it for right now. Like, just don't worry about the 3 till the very end. We're focused on this inside piece here right now. So we're going to have an x squared and the minus 30. Those don't change. But this inside piece here, this 13x, we found a way to rewrite it. So this is plus 15x minus 2x. We got those because these are the numbers that we came up with. Could I have written it as a minus 2x here and a plus 15x here? Sure, totally fine. That would have worked too. Now we have 4 terms, so we actually can use what's called factoring by grouping when you have 4 terms. And that's going to teach you this part too. So I'm going to show you how to factor by grouping. We're going to take each group, so the first and the second group of terms. We want to factor out the GCF of this first group, x squared plus 15x. The GCF there is 1x, or just x. We're going to be left with x plus 15 on the inside. Now, what is the GCF here? Well, if you look at it as 2x and 30, you can take out a 2. But since the first term's negative, we actually want to take out a negative 2. What are we left with on the inside? We'll be left again with x plus 15. That's another way you have to take out a negative 2, because you have to be left with the same thing in parentheses here. All right, our final step, we're going to take what's on the outside, this, x minus 2, and we're going to take what's on the inside, x plus 15. That's our final answer. But wait, did you notice that we have a minus 2 and a positive 15? Those are the numbers that we came up with. Yes, we could have really just gone from finding these numbers to putting it in our final answer. I show this entire process because that shortcut only works when a. Okay, in this next example, we still are asked to factor a quadratic trinomial. Our first step is to see if there's a greatest common factor. There's not. I can do that quickly because the only factor of 5 is 5 and 1, but we don't care about 1. And 20, it's already not divisible by 5. They also don't have any variables in common. So we don't have a GCF. We move down and see that it's a 3-termed or trinomial, and specifically it is a quadratic trinomial because of the x squared. In this case, a is not equal to 1. It's greater than 1. A is 5. We are still going to approach this in the same way. Our first step is to multiply a times c. A times c. And when we do a times c, we'll get 75. So we want two numbers that are going to multiply to 75 that are going to add to 28. Okay, those two numbers that multiply to 75 that add to 28 are 25 and 3. Now, just so you guys know, if it's hard for you to figure those numbers out quickly, and you're like, how did you find that out so fast? A, I prepared this example beforehand, so I already thought about it. And B, I've been doing this for like 10 years. So if you're new to this, it's not going to be as fast. You might have to think about this step for a minute. That's fine. All right, so we are going to break apart and write this into 4 terms. The first term stays the same, and the last term stays the same. We're going to rewrite 28x using 25x and 3x. Again, the order does not matter. I just wrote it in that way. I don't know, I put the bigger number first. Okay, now we're going to do what's called factoring by grouping. First group, second group. We're going to take the GCF out of each group. The GCF of our first group is 5x, and we're left with x plus 5 left. The GCF of our second group is 3, and since this leading the way is positive, I'm going to put a plus 3, since it's positive. And again, we're left with x plus 5. What's left in parentheses needs to be the same in both parentheses, otherwise you did something wrong. Then we take what's on the outside, 5x plus 3, and we take what's on the inside, x plus 5. If you were to multiply those together, you would get back to this guy right here. So in order to check your work, you can always multiply. Factoring is just reverse multiplication. Now there is another method for quadratic trinomials, and that is called the box method. I think what I'll do is just create a video just on the box method for quadratic trinomials instead of putting it in here. All right, we are moving on to 4 terms, and essentially we've already done 4 terms because this is how you do 4 terms. So this last one will be pretty quick. Okay, I'm just going to do one example for grouping. So we want to factor completely. We want to first see if there's a GCF, so something common to all 4 terms. This term does not even have a number in front of it besides 1, so there's no number in common we can take out. And then they do not have any common variables throughout all 4 terms. It looks like x might be promising, but this last term doesn't have an x. All right, so it's 4 terms, and if factorable, we need to use the grouping method. So the grouping method has already been highlighted by how to factor a quadratic trinomial, but it's the same thing really. So I just picked a more complex example to show how grouping can work with multiple variables. We want to see what we can take out of the first 2 terms, and it looks like we can take out a 7, and we also can take out an x. Now since the beginning term's negative, I'm going to take out a negative. So I'm going to take out negative 7x, and then what remains? In the first term, what remains is just 5. Since negative 7x times 5 gets us back to negative 35x, negative 7x times x will get us back to here. So plus x. All right, out of our second grouping, what can we take out? What's our GCF of these 2 terms? It looks like they just have a y in common. And since the first term's positive, I'm going to put plus y. Then we're left with x plus 5 once more. Again, those 2 things inside the parentheses need to match. Now, why does this last step work? Why do we write what's on the outside, and then why do we write what's on the inside? It's kind of a complicated explanation, so if you don't care, then you can kind of just be done. But I will tell you that the reason behind this is 1 term, and this is another giant term, 2 terms. What do those 2 terms have in common? They have 5 plus x in common, x plus 5, whatever, the order doesn't matter. But they have the x plus 5 in common, and so we can take that out. We're factoring out this GCF of x plus 5. What remains in this giant term is a negative 7x. And what remains in this giant term is a plus y. And so that's why we say, hey, take the stuff on the outside, put it in 1 term, take the stuff on the inside, put it in one other factor. All right, that is factoring. This video went a little longer than I wanted to, but hopefully that helps you out a little bit. I will create another video that highlights the box method for quadratic trinomials.